Okay, today we're going to talk about the unit circle, and this is something that will carry on with you guys through pre-calculus and calculus. So if you can understand the unit circle now, it's going to be a lot easier for you later on when you're doing other trig things. We're going to build the unit circle in this video, and then we'll apply that to some of the questions in lecture 9-3. So this is just all about the introduction to the unit circle. If you guys are solid on that, you can skip this video. All right, so what is the unit circle? Well, the unit circle is a special circle. It's a circle with a radius of 1. And what that allows us to do then is directly measure sine, cosine, tangent, cosecant, secant, and cotangent values without having to solve for them kind of geometrically, but we can just use the values on the unit circle to evaluate those 6 trig functions. So it's kind of a shortcut for that. There are 4 sets of angles that we're going to put on the unit circle, and we're going to build them using the properties of special right triangles that we talked about in geometry. So this is going to refer to pages 12 and 13 on your chapter 9 note packet. If you don't have the note packet, then you can just print out the handout for 9-3 linked on the Google Doc, and it'll be the last 2 pages on that handout. All right, so I've given you guys a template for the unit circle. It already has the angles built into that, but we're going to talk about those, and then we're going to actually map them onto my blank unit circle, and then you can follow along and fill in the blanks on your unit circle. So here's what I'm going to do. We're going to start looking at individual angles. So if you have 4 different colored markers or pencils, it might be best for you guys if you're going to mark your unit circle that way. I'm going to do everything color-coded to kind of help us out, and that'll help us later when we're talking about radians, especially. So we're going to start with the 90-degree angle family. We're going to go from largest angle to smallest angle that we're going to map out on the unit circle. And imagine, right, if we've got a unit circle, that means we've got a circle with a radius of 1. So let me see if I can build a circle here. Circle with a radius of 1, its center is 0, 0. Center is the origin. I'm going to do the 90-degree angle family in pink. So the 90-degree angle family, that is going to first start us off at 0 degrees. We would also call that 0 radians. So I'm going to mark the angles both in degrees and radians. You already have that on your unit circle. Now, if this is a circle with a radius of 1, if I've mapped this onto the x and the y axes here, that exterior point, that point on the edge of that circle, becomes 1, 0. Because this is a circle with a radius of 1, that ordered pair xy value would be 1, 0. Okay, the next 90-degree angle that is in the 90-degree angle family is the 90-degree angle. So that is mapped there on the positive y-axis. That is 90 degrees, or pi over 2 radians. So that becomes really important as we count radians. And we'll do that in 9-3. Again, the point sitting here on the exterior of that circle, if this is a circle with a radius of 1, that point up there is 0, 1. Okay. Moving along, the next 90 degrees. So if you guys can see the pattern, we're just counting by 90. We're starting at 0 degrees and counting every 90. This is then 180 degrees. Now, if 90 degrees is pi over 2 radians, then we go another pi over 2 radians to get to 180 degrees. So we're now at 2 pi over 2 radians, or simplified to pi radians. And this is the point -1, 0. So the radius is 1 of this unit circle. To get to the left of the origin, we have to go -1 units, right? So we're mapping this onto the x and y axes. Okay, another 90 degrees down here, which means another pi over 2 radians. This is 270 degrees, or 3 pi over 2 radians. So count them. 90 degrees is 1 pi over 2. 180 is 2 pi over 2. 270 is 3 pi over 2. And down here, sitting on the negative y-axis, that is the ordered pair 0, -1. All right, so that is our 90-degree angle family. I will go back and I will map that onto the unit circle, but I'm not going to show you guys that in the video. I'll just do it at the very end, and then you guys can pause and fill out the unit circle there. Okay, so those are the first 4 angles that are going on the unit circle. Those are actually already filled out on your unit circle if you're looking at page 12 of the note packet. Okay, so then the next angle family that we've got is the 60-degree angle family. This is the one I'm going to mark in green. We're going largest to smallest, so 60 degrees is that next special angle we're going to put on the unit circle. So again, I'm going to draw a circle with a radius of 1, and I'm going to ignore all those 90-degree angles, so I'm going to start kind of fresh and just mark the 60-degree angles here. So starting at 0 degrees, that's already part of the 90-degree angle family, so we're not going to repeat that. So then I'm going to go 60 degrees, and 60 degrees is going to get me this angle right here. Okay, so this is our first 60-degree angle. Now, 60 degrees in radians is pi over 3. All right, we're going to come back to that ordered pair that represents the point sitting on the exterior of the circle. What I'm going to do first is actually just count out all of these angles and mark them. So we went 60 degrees, which was pi over 3 radians. Now we're going to move another 60 degrees. Another 60 degrees gets us here. That was also not one of those angles on the 90-degree angle family, so this is its own unique angle. That is 120 degrees, right? 60 plus 60 is 120. Now, 60 degrees is 1 pi over 3. 120 is going to be 2 pi's over 3 then. All right, if I move another 60 degrees is 180. Now, 180 is already part of the 90-degree angle family. I'm not going to repeat that again, but 180 degrees, that's also 3 pi over 3, which was pi radians. So that's not part of the 60-degree angle family. I'm just going to mark that with a dashed line so we know that it's kind of there. It's part of what we counted. Okay, going another 60 degrees, we're now down here in the third quadrant. That is the angle 240. Now, if we go back and count in radians, we had 1 pi over 3, 2 pi over 3, 3 pi over 3 was 180 degrees, so 240 is 4 pi's over 3. Radians are really tricky, and the easier they become to you, the easier trig and pre-calc and calculus is going to be. All right, another 60 degrees. We're moving over here. Okay, that's not part of that 90-degree angle family that we had. That is 300 degrees. Now, if 240 degrees was 4 pi's over 3, then 300 is 5 pi's over 3. Every 60 degrees we move, we're moving 1 pi over 3. And then the last angle to end up back at a full circle is 360. Again, that's already part of the 90-degree angle family. 360 is coterminal with 0. We'll always state it as 0. So those are the 4 angles that are part of the 60-degree angle family. But let's talk about those ordered pairs that sit on the exterior of our unit circle. Now, this is going to require us to go back to geometry and think about those special right triangles. So I'm going to draw a special right triangle that has an angle of 60 degrees. So imagine I took this special right triangle right here and I just moved it over to the side. Okay. So essentially I dropped a perpendicular down to the x-axis, made a right triangle. That's what I've marked over there on the side. Okay, what do we know? Well, what else do we know? I know that if that is 60 degrees and the bottom right corner is 90, then the top must be 30. This must be a 30, 60, 90-degree triangle. We also know this. We're dealing with the unit circle, which means that the hypotenuse of this triangle is 1. The hypotenuse of the triangle is the radius of our circle. And that is the point that we're trying to find. We are trying to find some x and y value that represents that point sitting on the exterior of the unit circle. And then I'll explain why that matters later. Okay, so relationship between 30, 60, 90-degree special right triangle side lengths. If you know the hypotenuse, then the short side is always half that. So if the hypotenuse is 1, our short side is just 1/2. And then knowing the short side of a 30, 60, 90, the longer side is always the short side times the square root of 3. So the short side, 1/2 times the square root of 3 is root 3 over 2. So what happens then is that ordered pair sitting on the exterior of our unit circle in the first quadrant becomes 1/2 root 3 over 2. We move to the right 1/2 and we move up root 3 over 2 in order to get to that point on our unit circle. Now, because these angles are all part of the same family, they're going to carry the same x and y values. We're just going to change the sign between negative and positive depending on the quadrant. So if I move over to 120 degrees, x values in the second quadrant are always negative, so this is negative 1/2. The y value is still positive, still root 3 over 2. So the x and y values are going to be the same. The sign is just going to change depending on the quadrant. So down here at 240, this is going to be negative 1/2, negative root 3 over 2. Okay, x is always going to be 1/2, y is always going to be root 3 over 2, and then the sign changes depending on the quadrant. In the fourth quadrant, x is always positive, y is always negative. So those are the 4 points that are related to the 60-degree angle family sitting on the unit circle. All right, moving on. We're going to go to the 45-degree angle family. There are 4 angle families total, so we're halfway through. Okay, here's my unit circle again. 45-degree angles, I'm going to mark in blue. Okay, so starting at 0, we're moving on because 0 is part of the 90-degree angle family. 45 degrees is going to cut right through the middle of the first quadrant. So that is 45 degrees. Now, 45 degrees in radians is pi over 4 radians. Okay, so count again. Another 45 degrees takes us to 90 degrees. Now, 90 degrees is already part of the 90-degree angle family. We're going to leave that alone. But that is 2 pi's over 4. 45 degrees is 1 pi over 4. Then we go to 2 pi over 4. Now we're going to go down the middle of the second quadrant. That becomes our next angle. This is 135 degrees. Now in radians, 1 pi over 4, 2 pi over 4 is 90 degrees, so 3 pi over 4 is 135. And then we move on. Another 45 degrees, we're actually on the 180-degree angle. So we're not going to mark that as part of the 45-degree angle family, but that would be 4 pi over 4, which is pi radians. Okay, moving on. Down here, right through the middle of the third quadrant is going to be our next angle. This is 225 degrees. Now, if 180 was 4 pi over 4, this is now 5 pi over 4. We moved another pi over 4 to get to 5 pi over 4. Another 45 degrees or another pi over 4 gets us to 270, already part of the 90-degree angle family. So the last 45-degree angle that goes on the unit circle is this one down here. That's 315. Now, 5 pi over 4 was 225, so 5 pi over 4. 6 pi over 4 is 270, so 7 pi over 4 has to be 315. And then technically we'd end up back at 360 or 0 degrees. Those are coterminal angles. That is already part of the 90-degree angle family. So those are the angles for the 45-degree angle family. Now let's talk about that special right triangle. So again, if I were to drop a perpendicular to the x-axis to create a right triangle here, I'm going to pull that right triangle out. This is a 45, 90-degree triangle. Because this angle is 45, that makes this angle 45. The hypotenuse, again, is 1. It's the radius of that unit circle. So what do we know about the relationship between the sides of a 45, 90? Well, we always take the short side and we multiply it by the square root of 2 to get to the hypotenuse. So going backwards, taking the hypotenuse, we divide by the square root of 2 in order to get to the sides. Now, 1 over root 2, that is not rationalize. You cannot leave a radical in the denominator. So we are going to rationalize that, and that becomes the square root of 2 over 2. So the two side lengths are root 2 over 2. That means that the ordered pair that makes up the x and y values of 45 degrees, root 2 over 2, root 2 over 2. So the 45-degree angle family is really nice, and that the x and y values are the same. Now remember, we're going to carry these around the unit circle, and only the signs are going to change depending on the quadrant that we're in. So quadrant 2, the x values are negative. Quadrant 3, everything is negative. And quadrant 4, the y values are negative. All right, so those are the ordered pairs for the 45-degree angle family. Last angle, here we go. The 30-degree angle family. Last one we're going to mark on our unit circle. Let me draw a circle here. Okay, so we got a circle with a radius of 1, and we're marking the 30-degree angle family now. So I'm going to do that in purple. And then I'll map all of these onto the one unit circle. 30-degree angles, let's mark those. So 30 degrees is going to be right here in the first quadrant. 30 degrees is pi over 6. Okay, if I go another 30 degrees, we're actually at 60 degrees. It's already part of the 60-degree angle family. So we move on. Another 30 degrees puts us at 90. So again, that's already part of an angle family that exists. Another 30 degrees, that is 120. That's already part of the 60-degree angle family. So then we move on, and we're down here in the second quadrant at 150 degrees. So that's our next 30-degree angle family angle. So let's count them. 30 degrees, pi over 6. And then we went to 2 pi over 6 for 60 degrees, and 3 pi over 6 for 90 degrees. 4 pi over 6 for 60 degrees, so 150 is then 5 pi's over 6. Okay, 180, already part of the 90-degree angle family, so we move on. This next angle here, that is 210 degrees. That is part of the 30-degree angle family. So 150 was 5 pi over 6, and then 6 pi over 6 was 180, so 7 pi over 6 is 210. And then we go on. The next angle here, that is 240. That's part of the 60-degree angle family. And then the next angle, 270, part of the 90-degree angle family. Next angle here would be 300, part of the 60-degree angle family. So the last angle that's part of that 30-degree angle family, that is 330 degrees. Now let's count the radians. So go back to 210. That was 7 pi over 6. And then 8 pi over 6. 9 pi over 6 is 270. 10 pi over 6 is 300. So 330 must be 11 pi over 6. And then 0 degrees or 360, that is again already part of the 90-degree angle family. Okay, last set of ordered pairs. So I am going to create that special right triangle. Now this time, the way that it's oriented is important here. This is now the 30-degree angle, and the 60-degree angle is on the top. The hypotenuse is still 1, still matches the radius of our unit circle. So let's talk about that. The short side now is over here across from the 30-degree angle. So the short side is 1/2, and then the longer side across from the 60-degree angle is 1/2 times the square root of 3. So in a 30-degree angle family, the x-coordinate is root 3 over 2. And the y-coordinate is the 1/2 value now. All right, so same thing applies. X and y values are going to stay the same. We're just taking those ordered pairs and removing them throughout the different quadrants. So over here in quadrant 2, that is negative root 3 over 2, 1/2. Quadrant 3, everything is negative. Negative root 3 over 2, negative 1/2. Quadrant 4 is going to be positive root 3 over 2. And then negative 1/2. Okay, so those are all the unit circle angles and their values. I am going to put them up on the single unit circle so you guys can fill that out. But let's talk really quickly about sine, cosine, tangent, cotangent, secant, and cosecant, and what that means in relationship to the unit circle. Okay, so the unit circle. Really important thing to note here. On the unit circle, the y values are going to represent sine. So go to 30 degrees on your unit circle. The sine of 30 degrees is the y value of that ordered pair. The sine of 30 degrees is 1/2. The cosine of 45 degrees then. The x values of all those ordered pairs represent cosine. So the cosine of 45 degrees is root 2 over 2. The cosine of 180 degrees is negative 1. Just look at the x values of all those ordered pairs. The sine values are represented with the y values on the unit circle. So where are these functions positive and negative? That's going to be the last really important thing that matters in 9-3. So think about it. Sine and cosecant. Cosecant is the reciprocal of sine. We're looking for where the y values on the unit circle are positive. So y values are positive, that means that's where sine and cosecant are positive. So if we're looking at the x and y values here, well, y values are positive in the first quadrant, and they're also positive in the second quadrant. So sine and cosecant are positive in both quadrants 1 and quadrants 2. Okay. All right, how about cosine and secant? Well, cosine and secant, cosine is the reciprocal of secant. These deal with x values. So where are the x values positive in the unit circle? Well, the x values are positive always in the first quadrant, and then x is also positive in the fourth quadrant. So cosine and secant are going to be positive in quadrants 1 and quadrant 4. Last two, tangent, cotangent, reciprocals of one another. Now, tangent and cotangent, that deals with y values over x values, or x values over y values if we're talking about cotangent. So it actually takes both x and y into account. So we're looking for where both the x and y values are positive, or they're both negative, because then we have a negative over a negative, which means it's a positive. So first quadrant, x and y are positive, and then the third quadrant, x and y are both negative, which means a tangent and cotangent are positive in quadrants 1 and quadrants 3. How do you remember this? Well, I think about it this way. I call it the salty sea. Okay, salty sea. Let's see. Salty sea makes a Z. That's where sine is positive in the second quadrant. All are positive in the first quadrant. Tangent's positive in the third, and cosine's positive in the fourth. And then the reciprocals also. Some of my students think of it this way instead. All students take calculus. That one works better because it goes in the order of the quadrants. But however you feel works for you, that's how we can remember what functions are positive in which quadrants. Okay, unit circles going up. You can pause the video and just copy all of the angles and all of the values into your unit circle on page 12, and then you can move on to the 9-3 lecture. All right, final unit circle. Pause the video, write everything down, make sure you're good. Done.